Bagh School. Today we are trying to go through the paper that we have taken in the mock 2 examination 2020. Here is the paper P1 for grade 12 and 13. In section A, we had about 30 MCQs which were to be attempted. For each MCQs, there was one option that was correct. So starting with the MCQs, the first MCQs is which formula represent the empirical formula of a compound. Here you can see that I have highlighted the answer, that is C2H4O, because it contains the simplest ratio of the atoms of each element present, while in B option, C and D options, the ratios can be simplified further. While in A, the ratios cannot be simplified further. So it is the answer of MCQs number 1. Now for the second MCQs, it was a graphical question. The relative first ionization energies of 4 elements with consecutive numbers below 20 are shown on the graph. One of the elements reacts with hydrogen to form a covalent compound with formula HX. Which element could be X? Here, as you can see from the graph, there are 4 elements A, B, C and D. So he is asking us a question that one element which has reacted with hydrogen to form a covalent compound, that is HX. So in this case, as you can see, that the highest ionization energy is of the 8th group elements, which are the noble gases. So before that highest ionization energy element, that is B, the element A belongs to group 7, and group 7 elements are halogens. They form HX with hydrogen, the binary compounds, while the element C here belongs to group 1, while element D belongs to group 2. So our answer is A, as A element is from halogens. It has the second highest ionization energy in the period, and it forms HX molecule, as X itself represents it. So A is the answer. Now the third MCQ is in which structure are 3 atoms bonded together in a straight line. So I have given the answer highlighted in yellow color, that is sulfur hexa. SF6. As you can see from the diagram, I've drawn the structures. The structure A belongs to polyethylene. There are many atoms of carbon linked together in the polymer, and there are many atoms that are in a straight array. So this can't be an option because he's asking for 3 atoms that are in a single array. While in the case of B, the compound was propane. As you can see, hydrogen, carbon, and hydrogen. 1, 2, 3, 4 and 5 atoms are in a single array, while the others are not. In C, this is a structure of silicon tetrachloride, which is a tetrahedral structure. There are no 3 atoms that are in single array. While in D, you can see I have outlined the 3 atoms that are in single array, that is sulfur, fluorine and other fluorine. 1 fluorine is upward and 1 fluorine is downward. So answer is D. Now coming back to our next MCQs, that was MCQs number 4. A fluorescent light tube has an internal volume of 400 centimeter cube and an internal pressure of 200 kilopascal. It is filled with 0.03 moles of an ideal gas. What is the temperature of the gas inside the fluorescent light tube? The answer is B. How it came? The formula was PV is equal to nRT. We had to find the temperature. For that, we have to divide PV by nR. Here the pressure was in kilopascals, so we have to convert it into pascals. So I have multiplied it with 10 raised to power 3. While the volume was 400 centimeter cube. I've converted it into meter cube by dividing it by 10 raised to power 6. So it has been converted into 400 into 10 raised to power minus 6. So dividing whole of the PV value divided by NR, and here mole number of moles is 0.03, and the R is the gas constant, that is 8.31 joule per mole Kelvin. So if you calculate the answer comes out to be 3.21 into 10 raised to power 2 Kelvin. I hope the MCQs are clear. The next MCQs, which was the MCQs number 5, one of the reactions in a lead acid cell is shown. A lead solid plus lead oxide solid in the presence of acidic environment is reacting with sulfate ions, and lead sulfate is formed along with water. Here you can see the lead solid that is having an oxidation number of 0, while in lead oxide the lead is having an oxidation number of +4, while in the product the lead is converted into +2. You can calculate the oxidation numbers. You can see that the lead 0 is converted into lead 2 positive, that means that it is oxidized, while lead 4 positive in lead oxide is converted into lead 2 positive, which means it is reduced. So the best statement for the answer is A, that is lead is both oxidized and reduced in this MCQs. Further going along, MCQs number 6, iodine and propanone react according to the following equation. If the concentration of propanone is increased, keeping the total reaction volume constant, the rate of reaction also increases. What could be the reason for this? We had four options. The right answer was option D. As there are more collisions between reactant particles per second at higher concentration. But if we would be increasing the concentration of propanone, then the number of particles of propanone would be increasing and their collision would be increasing. So the best option that comes out to be is option D. There might be a chance that you would be thinking about option A greater proportion of collusion is successful at higher concentration, but this is not right, because for an effective and successful collusion, the activation energy must be present within all of the molecules that are reacting. For the activation energy is required, so there is no change in temperature that is shown in here, or told us he told us in this MCQs. So we can't opt for option A. The right answer is option D. Further going to the MCQs number 7, 200 gram of water, or at 25 degrees Celsius, the water is heated to 75 degrees Celsius by burning 2 gram of ethanol. What is the amount of energy transferred to the water? This is an MCQs from the chapter enthalpy changes. He is asking specifically, if you would see the statement, what is the amount of energy transferred to water? He is not asking the enthalpy change for the reaction, as ethanol is burning. So he is only asking the amount of energy that is transferred to the water. So that was a simple MCQs. As the temperature has risen from 25 degrees Celsius to 75 degrees Celsius, the formula was Q is equal to MC delta T. Putting the values, the mass of the water here is treated as the mass here in the formula. C is the specific heat constant for water, while the change in temperature was 75 minus 25. The overall answer that comes out to be, that becomes 41.8 kilojoule. If you converted it into kilojoules by dividing it, the answer with 1000. The next MCQs was based on Hess's law. Sulfur can be oxidized. Here are the two equations: sulfur to sulfur dioxide, sulfur to sulfur trioxide, and is asking us a question that how the sulfur dioxide converts to sulfur trioxide, what would be the enthalpy change for this reaction. So I would have to go for the working of this. If you would see by the Hess's law, I have drawn here sulfur and oxygen react together to form sulfur dioxide, and sulfur and oxygen also react to form directly sulfur trioxide. From here you can see that there is an indirect path by head to tail rule, that is delta H1 plus delta H2, that is equal to direct path delta H3. Putting the values, by putting the values we could get the answer for the reaction, that is conversion of sulfur dioxide to sulfur trioxide, and the answer comes out to be minus 198.4 kilojoule per mole. Here the answer I have highlighted is D. Question number 9. This was a tricky MCQs. Hydrogen iodide was decomposed into hydrogen and iodine, and it was an equilibrium reaction, the reversible reaction. And the question was, in an experiment, B mole of hydrogen iodide were put into a sealed vessel at a pressure P. Thus, the initial moles of the hydrogen iodide that were put into the vessel was B. And at equilibrium, X moles of hydrogen iodide had dissociated. From B moles of hydrogen iodide that were initial, X moles have dissociated. So for the sake of working, if we would go through the working of it, you can see initial moles of hydrogen iodide are B, while the initial moles of hydrogen and iodine are not given by him, so they are considered to be 0 and 0. While at equilibrium, the X moles out of B have been converted into hydrogen and iodine by decomposition reaction. So by the relation, if X moles of hydrogen iodide have been converted or decomposed, so X by 2 moles of hydrogen would be formed and X by 2 moles of iodine would be formed. Here he was asking us about Kp. So we have to find out the partial pressures of hydrogen iodide, hydrogen and iodine. For that purpose, we had to find out the total moles that were reacting, that were present at the equilibrium. That comes out to be B. So that was here we have to find out the mole fraction for hydrogen iodide. The mole fraction was B minus X over total moles at equilibrium B, multiply by, now if you want to convert it into total partial pressure of hydrogen iodide, you have to multiply by pressure P that is given by the examiner. Same goes to for hydrogen. We have X by 2 moles at equilibrium of this reaction, while the total moles at equilibrium are B. So equation the mole fraction comes out to be X by 2B. For converting it to partial pressure, we have to multiply by with the total pressure that he has given. Same goes for iodine. This is how you can get the three values of partial pressures by using the formula of Kp. As you can see that I have written the Kp, partial pressure of hydrogen multiplied by partial pressure of iodine divided by partial pressure of hydrogen iodide squared. Now, by putting the values of the partial pressures of each gas at equilibrium and cancelling out the terms that are being cancelled, we get the answer, that is D, x square over 4b minus x whole square. Now, coming to the next MCQs, that is MCQs number 10, which fertilizer contain the greatest percentage of nitrogen by mass? There were four nitrogenous fertilizers. Thus, MCQs was simple. This is an MCQs that is also asked in O-levels papers. What you have to do here is that you have to find out the mass of nitrogen in each compound and divide it by the molar mass of each compound. By multiplying with the whole answer with 100, you would get the answer. And here the maximum percentage of nitrogen was found in uh, urea, that was 46.2. 67%. This was the right answer, while in A, B, and C, the percentage would be coming out to be smaller one as compared to the answer in D. Here the nitrogen amount of nitrogen in this compound urea is 28 grams, while the molar mass of urea is 40 is 60. So by dividing 28 by 60 and multiplying it by 100, we get 46.67%. That is the highest percentage of nitrogen in any of these four compounds, and the urea is the right answer. Hope boys, I am hoping that you would be finding these videos useful for your learning purposes, because we are only left with the option of online learning due to the COVID-19. Take care, boys. Thank you.